Hi friends, welcome to the tour of network analytics. In this particular presentation, we'll try to understand the fundamental concepts that help us visualize and understand the complex networks that are basically coming across various domains. To understand the networks, we first have to understand what is the kind of data that we are basically dealing on a day-to-day basis. In a traditional scenario, we try to deal with data which is in a tabular format. For example, the CSV files or spreadsheets or databases where data is arranged in a rows and column format. These are very simple and these are always in structured arrangement. We will have some kind of fixed relationships between the entities. They are more prominent for retrieving the data using queries, right? SQL queries, for example, we basically tend to do query data by writing certain SQL commands. So for traditional day-to-day transactional related data, this is the representation. But there are other type of representations that we also have to understand. And one of that is the network data. The network data is a graphical representation like in this image. And here we are trying to represent interconnected entities and of course the relationships between them in a graphical manner. For example, social media or your different relationships between websites or web pages, supply chain analytics, if we talk about that, the logistics. So we will have different type of entities and relationships between them. So how do we deal with such network data, which obviously is in an unstructured arranged format, which is in an untraditional form, right? The data is in a graphical representation. In order to understand this network data, we basically have to try and understand the components of this network data. You talk about any network data, the default elements of the network data are nodes and edges. Every network contains these standard elements. Nodes represent people in a social media, for example. If I talk about internet or LAN, we have interconnected computers, right? So computers would become your nodes or proteins and biological right structure. If I talk about, let's say, transport scenario, interconnected in aviation sector, in airports, we have interconnected flights, right? We talk about different airports. Interconnected flights will be taken. So you can visualize the airports as interconnected entities, and those airports will be our nodes. For example, I write an email. I become a node and I'm sending the email to, let's say, two of my colleagues. Both these colleagues become another nodes, right? Set of nodes. The other point in the network is the edge. Edge is nothing but the connection or the relation between the nodes. The nodes are also called as vertices. Edges are nothing but your connections between these vertices or nodes. Collectively, we get a graphical representation which can be represented like this in a diagram form, where the circles here are representing the nodes and the lines which are connecting these circles are our edges. These are the essential components that we need to remember. So if I have to talk about a network is always right, a combination of nodes and edges. These are the two components that we have. Or if I have to represent this as vertex, then I'll write this as V and edge. Now, in order to study this particular data, if I have to try and derive some insights on the network data, we need to try and understand the properties of the elements that give us this network. That means we'll have to study the properties of nodes and study the properties of edges. Collectively, these give us the overall representation of our network or overall insights of our network data. You can see these are a couple of or a few examples to explain the networks that are around us. Social media networks, right? This maps friendships or colleagues in LinkedIn, for example. And we will be able to try and understand the influence people among the network, or popular people in that network. Technological networks, again, as I mentioned, LAN, interconnected computers. So computers becomes our nodes. Internet becomes your entire network. If I talk about biological networks, the protein interactions, the neural connections, or the food webs, these are some of the examples. Now let us try and understand the properties in the network. As I said, in order to understand the overall network, first we have to try and understand the element properties. And here we are talking about edge properties. Edges are nothing but your connections. So I'm trying to study the characteristics of edges or connections. A connection can exist only when we have at least two vertices in the scenario in a network. A connection can exist only when we have at least two vertices. And we also need to understand that the connections can be directional as well. It can be going from one node to another node. So we can represent the direction as well. Right? So these are two very, very important properties that we need to look at. Next, if we talk about node properties, every node is connected with other node, right? May or may not be connected with all the other nodes or some nodes, or it may not at all be connected. So when we talk about each node, generally the properties or the characteristic of the node or the weightage for the node is directly proportional to the number of connections that it is getting. So we have to try and understand how a node is connected with other nodes. And these connections will help us understand the strength or the influence of that particular node in the network. Right? So these calculations basically are derived as centrality calculations. One of the most important calculation that we look at, or the basic trivial connection that trivial characteristic that we look at, is the number of direct connections a node can have. This significantly talks about the popularity of that particular node or the importance or the influence of that particular node. Right? Generally, this degree centrality is used to understand who is more influential in an entire social media network. For example, in India, Virat Kohli is very, very popular. Why? Because people try to connect with, right, or people try to follow Virat Kohli. So degree centrality is defined as the number of direct connections. But one thing is, the drawback of this degree centrality is it only considers the direct connections. What about the indirect connections? Right? So degree centrality does not look into that aspect. It does not look into the overall network to define a value for a node. And one more thing is, when we talk about degree centrality, we also have to bring in the properties of edges here, because node weightage comes from the network connections, right? Number of connections. So we are looking at the properties of edges or connections as well. The edges can be directional, or undirected. Unidirectional or directional. Directional means, if I talk about Twitter as an example, or X for the matter, we are basically looking at people following popular figures. Like I follow Virat Kohli, you follow Virat Kohli. More number of people follow Virat Kohli. Does that mean Virat Kohli is also following you? No, right? So this basically is the important aspect that we have to look at when we are considering degree centrality. There will be inward degree centrality and outward degree centrality depending on the type of connection that we are looking at. So your network also needs to consider the direction of the connection in order to establish this insights. If I talk about Facebook, for example, or LinkedIn for that matter, I send a friend's request in Facebook, or you send a friend's request to me. And when I accept, the connection is happening from both ways. So there is no direction that is defined here in Facebook. You connected with me or I connected with you. Basically, there is a connection between us. But unlike in Twitter, where you will have a specific direction of the connection. Okay. So very, very important to understand the importance of the node when you try and understand the characteristics of these centrality measures as well. So degree centrality, very, very trivial and very, very important characteristic. It talks about direct connections, and we also have to look at inward and outward connections. And the limitation is it does not look into the entire network. It only looks at the direct connections. There are many such centrality computations. One another computation is betweenness centrality. The betweenness centrality speaks about a node playing very, very important role of a bridge between other nodes in the community. Or a node is trying to connect two different networks altogether. So this particular node, which is connecting two different networks, plays very important role bridging those connections, right? Bridging those networks. It falls in between these two networks. So it will have very high betweenness centrality. So this is the way to look into the betweenness centrality calculations. We try to find out the most efficient routes between multiple node pairs. So we will take pairs, at least two nodes we will have to consider, at least two nodes or two or more. And then we try to count how often a specific node is appearing in the shortest path of any node pairs that we consider. For example, if I say this is A, this is B, this is C, this is D, this is E, and this is F, assume. Okay, this is our network connection that we are looking at here. Okay. And let's say this is G. So if I talk about a pair of connections, for example, A and B, this is one pair, but there is shortest path, there is no other node scope here. But if I talk about A and C, AB, yeah, there is one shortest path and there is no other node coming in between them. But if I talk about A and C node, there are no direct connections. So we have A, B, and C one path, A, D, and C one path. Shortest paths we will have to consider. We cannot consider A, B, F, E, C. That doesn't make sense. So there are two shortest paths. Out of this, one path is going through B. So if I have to talk about the betweenness centrality for the node B, then I will have 1 by 2. Because out of two shortest paths, the node that we are interested in is passing through, or this pair is, right, the connections are passing through that particular node. This way, we determine the scores for betweenness centrality for each node. And then the nodes with high betweenness centrality, they basically control the information flow between the nodes in that entire network. So this is a very short glimpse into the study of networks. There are various tools that we can use, and we will be looking into, most importantly, the NetworkX library in Python, very, very popular for creation and managing of networks, manipulation of networks. This is what the official documentation of NetworkX library also speaks about. It helps us analyze the entire network structure using different functions that are made available in this module. So we will try and do hands-on in the upcoming videos on how NetworkX can actually help us evaluate and derive information out of various networks. There are other tools also. If you are familiar with R language, you can use iGraph or StatNet, Neo4j, uh, Kitospace, right, etc. We have Gaphy is also there, which is a visualization platform to interact with your networks. So these are some of the tools that we can work with, and practically these are some of the use cases where network analytics can play a crucial role. For example, in marketing, we talk about customer segmentation or market segmentation, right? And we can also try and build net recommendation engines or recommendation systems depending on the various connections that we see. In security, fraud detections can happen, or cyber threat analysis can be performed by studying the networks. Of course, social media, yeah, social sciences there, then health and medicine. So these are some of the areas where study of networks can help us develop very, very interesting solutions to address the challenges in their respective domains. So that's a quick intro. Thank you for watching. And we will connect in the next video and try to explore more about the study of networks using NetworkX. And we will try and see how we can try and develop some applications to solve certain challenges in very, very interesting domains. See you in the next video. Thank you all.